Just as you wouldn't drink a glass of dirty water, you wouldn't choose to breathe in dirty air. So what if you could see the air in such a way that you could know how much pollution you and your family are exposed to? How would it affect your lifestyle, how you travel, how you live, or even where you live? Well, that's what I've developed. A machine that allows you to see the pollution all around you. My name is Mark Richards. I've got a passion for physics, and I've found through the machine I've developed a way of applying it to something both meaningful and practical. But like most inventions, it starts off as a piece of research. I'm using this clean water to represent clean air, and when I shine a beam of light through the water, it goes through, fairly uninhibited. However, if there are pollutants present, then that pollutant will absorb some of the light. And this is because when light hits a molecule, that molecule will absorb some and transmit the rest. As a result, the beam gets weaker. I can use this principle to measure the amount of pollution in this water. If I was to conduct a similar experiment in the air, most pollutants are not visible. They absorb very little visible light. Luckily, many pollutants absorb light outside of the visible range, ultraviolet light. Instead of visible light, I can direct an ultraviolet light beam through the air, and any chemicals which are present will absorb specific wavelengths. Each pollutant has its own signature in the ultraviolet region. The resultant beam is measured with something called a spectrometer. I've aligned the optics, I've also connected the source and the spectrometer. Finally, I've run some air through this chamber and also injected some pollutants. So let's look at the results. The large peaks here are due to sulfur dioxide, an important pollutant. It's mainly produced by heavy industry and also diesel engines. You can see these smaller peaks which are due to nitric oxide, emitted by petrol engines. This setup actually allows me to detect many different gases simultaneously. And not only that, we can actually measure how much of each gas is present. So, now I can see pollution, which is great, but this is just an experiment in the lab. The challenge is how I can adapt this for use in the real world. I helped to set up a company with engineers and business people, and the aim was to develop a machine that measures pollution that is portable. The optical path of the ultraviolet light beam has to be quite long, so I use a series of UV reflective mirrors to create multiple reflections so that we can make the unit short enough to carry. In order to complete the unit, it requires a clever computing algorithm and supporting electronics that allows us to take measurements every second. Now this makes it ideal for mobile sensing. So I'm here at the inside the quad at Imperial College, and I was just actually checking the pollution levels. It seems pretty good so far. Sulfur dioxide is near enough 0 parts per billion. Nitrogen dioxide, 28 parts per billion. The legal limit is about 105. So these numbers are incredibly encouraging. But of course, we might see dramatic changes onto the road side. Junction here. As you can see, multiple lanes of traffic in several directions. Let's have a look what the numbers say. Well, both nitric oxide and nitrogen dioxide, they're both above 100 parts per billion. But the key thing here is that at traffic lights, whilst cars are idling their engines, they're not being overworked. But when the lights change, the cars will start to rev their engines. And as a result, the emission levels will start to spike quite dramatically. I've managed to couple the unit with GPS, which means I can now map pollution readings to exact locations. And when you combine this with the fact that I can measure every second, it means that I can now generate a pollution map, a bit like a weather map. Furthermore, you can actually update this map in real time. That means as the pollution changes around you, you can see the changes straight away. So if you're an asthma sufferer, for example, you can actually have a look at this map and decide where to go or when to go. Okay, so this is the data.
Yes.
Great. Can we go to this? Is this the southwest corner that we were at?
Yeah, I think so.
So this is the quad at Imperial College where we started. If we start to include nitrogen dioxide, now we can see a huge spike at the junction.
It's really a high pollution level.
Yeah, this spike's interesting actually, because this was when we were near 3 coaches. One of them was idling their engine, and just that one coach idling its engine has caused this huge spike here. Now, I've just put the unit in a weatherproof case. This means I can stick it on top of my car, which means I can cover a much wider area. And I can go on to map the whole of London like this, driving around seeing how pollution varies from area to area, street by street. The implications for this technology are huge. In the UK alone, over 50,000 deaths are attributed to air pollution each year. There's increasing public concern, and with this machine, we can really find out how bad pollution is for the first time. The bottom line is, if you knew more about air quality, you could build a better environment around you. If you knew more about the pollution levels around a school during the school run, it might influence parents' travel habits. So, with my physics, I've managed to develop something real, something useful, but more importantly, something that helps to improve the quality of life for my family by allowing them to see the air they breathe.